Today, we step into the orchestra of the universe, where forces compose the music of motion. Let's begin with a simple question. What is a force? It's a push or a pull, the invisible hand that sets things into motion or brings them to a halt. Now, imagine a child spinning on a merry-go-round. The motion is circular, but the force is not. A special force called centripetal force pulls the child toward the center, keeping the motion in a perfect circle. Without it, they'd fly off in a straight line, carried by momentum. Force is the composer in this symphony, guiding every motion. It's linked to mass and acceleration by a simple rule: force equals mass times acceleration. A heavier object or a quicker change in motion needs more force, just like a larger drum needs more energy to produce a sound. And what happens when two forces act together, like these ribbons pulling in different directions? We find the resultant force, the vector that combines them. If the forces act at right angles, we can use a simple trick, a right triangle, to calculate their combined strength and direction. Here's another secret. Some quantities, like speed, are scalars. They have only size. Others, like velocity, are vectors. They tell us not just how much, but where. Think of a ship on the sea. It's not enough to know how fast it moves. You must also know its direction. When we talk about changes in motion, we meet two important friends: momentum and impulse. Momentum is the motion locked inside an object, depending on its mass and velocity. And impulse? It's the force acting over time to change that momentum, like a kick that sends a ball flying. And why does all this matter? To design safer cars, understand how rockets launch, and predict the paths of planets. Forces are the threads weaving the fabric of the universe, connecting everything in motion. Now, draw the vectors, calculate the forces, and listen closely to the symphony of motion.